Okay, on to number 3b. Say we have a particle with mass 1 starting at position 0, 1 with an initial velocity negative 0, 1 and no initial acceleration. The particle is at one end of the spring whose other end is the origin 0, 0. So I've kind of drawn out a picture here for you. This is the spring, and these are all the initial values we're given. Calculate the particle's position at t equals 3 using the explicit Euler method with time step 1. Alright, so I've also written a couple equations over here on the side. This is the Euler method from above, and this is one of the spring calculations. This one is without internal damping, and this is just Newton's law. Okay, so let's get started and calculate our position at time step 1. That's going to be our position at time step 0 plus our velocity at time step 0. So that's just going to be negative 1, 1. And then our velocity at time step 1 is going to be our velocity from time step 0 plus our acceleration. Our acceleration is 0, so that'll be nothing. And then we want to calculate our acceleration at time step 1. And that's going to take a little bit more math because we have our spring. I drew it right here. So at time step 1, it's going to be stretched out a little bit, and then it's going to be enacting some force on our particle. So since we have force equals mass times acceleration, then our acceleration at time step 1 is going to be our force divided by mass. So what's our force? Let's calculate that here with our spring equation. So our K equals 1, and then we have B minus A. So in this, our B is right here, so that would be negative 1, 1. Our A is the origin, and then we want the norm of that. And then we're going to multiply it by this. Minus 1 because our rest length is 1. Okay, and this, I'm just going to add our 1 over m term here because we're calculating acceleration. Alright, and then if we just simplify this, we're going to get 1 over m, negative 1, 1. This is going to be root 2, and then this will be root 2 minus 1. Okay, so then we can just simplify this a bit more. So we'll have for our x negative 1 over root 2 times root 2 minus 1. And then our y, 1 over root 2 times root 2 minus 1. And then obviously we have our mass term here as well. And it says that our mass is just 1, so we're omitting that. Alright. So now that we have our acceleration for time step 1, let's move on to time step 2. So we have x2. Our position is position at time step 1 plus our velocity at time step 1. Okay. that's fairly straightforward. We're just going to have negative 2, 1. Our velocity at time step 2 is going to be our velocity at time step 1 plus our acceleration. And that's going to be negative root 2 over 2, root 2 over 2 minus 1. I simplified it a little bit. Alright, and then x dot 2, we're actually not going to calculate our acceleration at time step 2 just because it asked us in the original equation just for the position at time step 3, and we can already calculate our position just given our position at time step 2 and our velocity at time step 2. So let's just go ahead and do that, and we can avoid all the unnecessary calculations. So then we're just going to have negative 2, 1 plus this, and that's just going to give us our final answer. Oh.